Our discussion for today is about logic. And when you say logic, it is associated to correct reasoning or correct thinking. And then in logic, we have this concept about arguments. And when you say arguments, these arguments have two parts, which are the premises and the conclusion. In some other references, they call these premises as hypothesis. Anyway, in every argument, you could have one or more premises, but there can only be one conclusion. And your conclusion can be either logically true or logically false. And then another concept under logic is we have the propositions, and then under propositions we have five types. We have the negation, we have the conjunction, disjunction, conditional, and biconditional. These are the five types of propositions in logic. Now let us try to write statements into compound propositions. Anyway, when you say compound propositions, it is composed of two or more statements, and otherwise, if it will only be composed of one statement, that is what we call simple proposition. Now, dealing with compound propositions, let us try to have an example here, which is about mathematics. So we have here two statements. Mathematics is a difficult subject, and the other one, it is time consuming, and then that it refers to mathematics. Now, if you are going to write this in a compound proposition, let us try to consider the five types of the proposition, which again are the negation, conjunction, disjunction, conditional, and biconditional. So let us start with the negation. Now, in a negation, we only be using one statement here, which is the mathematics is a difficult subject. And then to negate that, it will be mathematics is not a difficult subject. Well, anyway, in terms of negation, it doesn't mean that the statement that has the not word is already a negation, because in some other instances, you could have a statement which is, for example, your statement there is that mathematics is not a difficult subject, then its negation would be mathematics is a difficult subject, which obviously doesn't have the word not for its negation. And then the next one, let us have, with the same statements, let us have the conjunction. Now for the conjunction, it will be mathematics is a difficult and time-consuming subject. Now it is emphasized there, the word and, which actually refers to our conjunction. And then the third one is about disjunction. And for the disjunction, using the same statements, mathematics is a difficult or time-consuming subject. And it is also emphasized there, the word or, which refers to our disjunction. And for our fourth one, which is a conditional statement, which is most commonly known as the if and then statement. So we have here, if the subject is mathematics, then it is difficult. So you have there the words if and then. And then the last one, which is a biconditional, the subject is difficult if and only if it is mathematics. So you have there the phrase if and only if that makes it biconditional. So these are the five types of proposition, okay, being used in our example here, given the two statements, mathematics is a difficult subject, and the other one, it is time consuming. Now, focusing on conditional statement, if and then statement in other references, they call it as the if and then statement. Okay, referring to that conditional statement, let us try to write statements. Okay, given statements into that conditional statement. So an example here, we have a simple statement here, which is a diligent student is loved by his teacher. Now, if we are going to write this into a conditional statement, of course, we have to use the words if and then. And that would be, if a student is diligent, then he is loved by his teacher. So that is how we write a particular statement into a conditional statement. Another example. So we have here a statement that says a square is a rhombus. And to write that into a conditional statement using the if and then words, it will be, if the quadrilateral is a square, then it is a rhombus. Now, if you are not familiar with the word quadrilateral, because it is known to be a jargon, in the field of mathematics, you could have another word, which could be figure or shape. So you could have a statement such as this: if the quadrilateral, if the figure is a square, then it is a rhombus. Or you could have, if the shape is a square, then it is a rhombus. So that is how you write statements into conditional statement or into if and then statement. Okay, next, again, focusing on conditional statement, let us try to write now this statement into its converse, inverse, and contrapositive. Now let us try to go back to the definition of each statement. Now, if we have our conditional statement in if and then statement, we should have two statements here. So we have to let P be one of the statements and Q be the other statement. So by that case, conditional, if P, then Q. So that is our conditional statement. And for our converse, it will be if Q, then P. And then next one, for our inverse, it will be if not P, then not Q. Anyway, this symbol here is actually a symbol for a negation. Now, if you notice, the inverse is the negation of conditional. So if conditional is if P then Q, then your inverse will be if not P then not Q. And our fourth one, which is our contrapositive, it will be if not Q then not P. Again, if you notice, this contrapositive is the negation of the converse. If your converse is if Q then P, the contrapositive is if not Q then not P. So obviously it is the negation of the converse. And it could also be the reverse of your inverse. If your inverse is if negate P, then negate Q. For a contrapositive, it will be the reverse. So if negate Q, then negate P. So you could have those ideas so that you will not be having difficulties in terms of writing conditional statement into its converse, inverse, and contrapositive. Okay, so I hope this is now very clear. Now let us go to our example. So we have here an example of a conditional statement that says if the student is diligent, then he is loved by his teacher. So if you notice, this example appeared already in our previous slide, so I will be using this example here. So again, our conditional statement, it says that if the student is diligent, then he is loved by his teacher. Now let us try to write this conditional statement into its converse. So the first one, for its converse, so in this case, the student is diligent, that would be our P. He is loved by his teacher, that would be our Q. So for its converse, it will be now if the student is loved by his teachers, then he is diligent. Okay, so the P here will be the Q in the converse, and then the Q here will be the P in your converse. Now the next would be the inverse. So again, just like what I have told you a while back, the inverse is actually the negation of your conditional statement. So let us now try to negate this. So if the student is not diligent, then he is not loved by his teacher. So obviously, this one is negated. This one is also negated. Okay, next for our contrapositive. So our contrapositive could either be the negation of the converse or the reverse of the inverse. So if you're going to negate your converse, then that would be our contrapositive. So by negating this and by negating that, we will be having our contrapositive. If the student is not loved by his teachers, then he is not diligent. Okay, so let us have another example to write conditional statement into its converse, inverse, and contrapositive. So another example, we have it here. If it rained, then the road is wet. So that is your conditional statement. And then its converse would be if the road is wet, then it rained. And for our inverse, which is the negation of conditional, will be if it did not rain, then the road is not wet. And then again, for the last one, our contrapositive, which is the negation of your converse. So if the road is not wet, then it did not rain. So this is how you're going to write your conditional statement to converse, inverse, and contrapositive. I hope these are very, very clear to you. And again, if you want to have some more examples, you can just browse the net, surf the net, or try to skim some books, especially on logic, of course. Okay, So let us go to the next topic, which is about the truth value of the statements. Anyway, in every statement, it doesn't mean that every statement is logically true, because it can also be logically false. So that's why it is important for us, or significant for a statement to have the truth value. Now, in terms of assuming the truth value of the statements, for a conditional proportion, it is has to be based on, of course, on premises. Okay, but by this time, for an example, okay, going back to our previous example, if the subject is mathematics, then it is difficult. Now we are dealing with conditional statements here. Okay, so for conditional statement, if and then, so if the subject is mathematics, then it is difficult. Now let us assume that this is true. Okay, that if you are in a class of mathematics, then you would expect that it will be difficult. So let us assume that that is true. If we are going to get its converse, if the subject is not difficult, then it is mathematics. So assuming that the conditional proposition is true, then this converse will be false. So if the subject is difficult, then it is mathematics, because it doesn't mean that it doesn't mean that if a subject is difficult, if you find a subject to be difficult, then you would automatically think of mathematics. So that's kind of unfair for the subject mathematics. So the converse would be false. And then let us try to get the truth value of the inverse. So the inverse now, if the subject is not mathematics, then it is not difficult. So it would be false. So same reason as we had for the uh, converse. And then for the contrapositive, truth value of this statement, if the subject is not difficult, then it is not mathematics. So by assuming that the conditional proposition is true, then you would expect that your contrapositive would also be logically true. I hope you get that. Okay, so let us have another example referring to the truth value of the statements. Now let us have this example that we had before. So if it rained, then the road is wet. So let us assume that this is true. Then the converse would be false. If the road is wet, then it rained, because there could be other reasons why the road is wet. Now, for its inverse, it will be logically false. And then for the contrapositive, then it will be logically true. Now, if you want to understand this one better, or to have much clearer approach on understanding the truth value of the statement, so just like what I've told you before, just try to skim some books on logic, and then also in geometry, because logic is being used in geometry, especially on theorems, propositions, and the like. And then there are already many video lectures about this. And again, you may browse or surf the net. Okay. Now, so these are for the truth value of the statement.